on to problem 12. We want to know the isomeric relationship between these compounds. And we're given a Fisher projection and a Newman projection. Okay, so we know how to do this the long way, which is doing R and S, as I've discussed in another video. I can link that to you guys on the description below as well if you want more practice with these. But the way we do them often is to look at the Fisher projection, and if your lowest priority group is on the horizontal axis or on the left and right, the arms of the Fisher projection, and not up and down like this up here, that lets you know that you have to flip the orientation after you number it. So that means that going through this, I would number these accordingly. Br is going to be heavier than carbon, so that'll be our first priority. Then this carbon over here has this chloride attached, which is going to make it, and that chloride has a higher priority than these H's, so we're going to have that at 2, this at 3, and that at 4. So now we do it like normal and connect these, and we're going to the right, which means clockwise and R. But since 4 is on the arms, we say that it's actually S. Okay, on to the next one. We can number these about the same. The halogen's gonna beat this carbon, and then this is gonna beat this these H's, so we can go here. Again, the 4 is on the low group, so we have to flip. Here we're going to the left, which means it's actually R. Okay, so now we know that our Fisher projection, top to bottom, is SR. Good to note that this is not a meso because of these two different groups, so we don't have to worry about that. It's just an SR from top to bottom. Make sure that this is the same. Here we're looking at it, the crosshair is always what's on top. So really, we're gonna have to switch these groups for this because we numbered it from bromine on top. So here we have chloride on top. So that's essentially if these two groups were switched. Okay, so that means we have to switch the two orientations after, unless they're of course the same thing, which would be nice. I doubt it. Let's see. Okay, so we have on this, we do this the front by assuming that we need the 4th priority group in the back or the front, basically on a different plane. All the ones on the front of the group are going to be wedges, because if we look at a actual projection on our model kit, these are going forward, and then this circle in the back is going away because that is the carbon in the back. So that is actually a dash, and here it's a carbon, and we're going to say it's attached to that Br alone, even though there's more, but that's the biggest priority group. So let's start numbering. We have a chloride, which was first, then this dash, then the methyl group, and then this is the lowest. To do these, we need this in the back, so we'll swap it around using our swap method. Swap method, again, we went over in the last video, but if we can do that by switching these numbers right here, so it ends up in the back. And if we switch, we have to switch twice, because this, if we did it right now, it would give us the opposite configuration. So we're going to switch, let's say this 3 and this 2 as well. Now we can do it like normal, and we end up with it going to the S direction. And because our low priority group is dashed, just like in a normal perspective drawing, when it's the 4th group is out and dashed, we keep it the same. And if it was a wedge, we'd flip it. Here it's dashed, so we're going to say that this is an S. And again, this is backwards, so really there's something in front of this S, so we already know that at best we are just distereomers. But could be enantiomers as well. So let's look on to the back carbon, and here in this case the carbon here is represented by the circle, and all these would be dashes because it's facing away from us. And the wedge in this case is the crosshair in front, which is attached to a Cl. In other words, it's this carbon right here, drawn out by that. Okay, so now we have to prioritize our groups. We have 1, and then chloride's going to beat out that, just like before, 3 and 4. So we want this to be on the different plane, so if we want it to be on a wedge, unique into the dashes. We always want this forward on a different spot, because it has to be on a wedge on our dash if it's switched. So if, let's say if they were all wedges like before, we needed it on a dash. If they're all dashes, we need it on a wedge. So let's see. We need to swap that 4 with this 2. That way it's on the wedge, and when we swap ones, we have to do it again. So let's watch the 3 and the 2. Again, it doesn't matter which ones you swap. You can do it with any of those on that move, as long as it's not the wedge, because you want that to stay there. Okay, and we'll finally just draw our arrows. Here we're going S, but because our group is our lowest priority group's on the wedge, we flip that, just like in the perspective drawing, and we actually have an R. So we have our relationship being R S. That will leave us with enantiomers, and since they're not meso compounds, we know for sure they're enantiomers. Another way of doing this is of course in your head. That's honestly the better way, because if you need to, a lot of the times you're really constrained by time on these. But if you need to do it this way, do it quick, go back and check afterward.